then you are all being recorded, and you guys are going to be on the internet, so you got to be good. Okay? All right, so, and when you guys ask a question, in case I can't hear it, I might repeat it just so that if it doesn't, because I don't know how well the sound's going to show up on here yet, so I'll repeat it and see what you have. Okay, how many of you got it now? Let's see if we got it. Okay, Dietrich, what are we going to do to find the vertex? What is the vertex? What do you think it is? You say it's -7 what? -19. Anybody agree with him? Okay, someone else says 7, -19. Anybody else? Stephanie, what did you have? Huh? -7 and 79. Anybody else have an answer? What do you think? Who else had the answer? Come on, let's see. How many of you had one of these three answers right up here? Okay. Anybody have a different answer? Let's put a couple more answers. I'm not even sure what it is yet. I haven't even tried it. I just made this problem just 10 minutes ago. 779, you think it is? Okay. Anybody else want to give one more? Okay. Let's go through and find out how to do it. Okay, here we go. We have y equals x squared plus 14x plus 30. And we are... Say that again? Say that again. I couldn't hear you, Lacey. No, that's when we are factoring them to find the x-intercepts. Remember, we're trying to to find the vertex, we're going to put this in vertex form. Okay, so what do we have to do to put this in vertex form? Okay, we're going to have to take a half of 14. What's half of 14? 7. And then what do we do with that number? Square it. What's 7 squared? 49. So we have y equals x squared plus 14x. And remember, we group these first two terms right here. And this is called completing the square. We've completed the square with that number. When we took half of 14, we got 7. We squared it. We got 49. Okay? So that's completing our square. Now, can we just add any number to the side of the equation without compensating for it? So what else do we have to do? Minus 49. Okay. Now, we've completed the square. What's your question, Shiley? Well, yeah, because I just added 49. Think of a balance scale. If I took a balance scale and I also add 49 pounds to one side, all of a sudden it's going to go like this, right? So if I have to take off that 49 to balance it back out. So yeah, whatever the opposite is. This number, though, is always going to be what kind of number? Positive. Why? Yeah, I just squared 7. And so anytime you square a number, you're going to get a positive number. So in every case, I'm always going to minus that number. Okay. All right, now, looking right here, x squared plus 14x plus 49, right here, I have to factor that. Okay. Okay. Remind me of your names. It's Alex. She just checks in here, so I'm just learning their names. Alex said 7 times 7 is 49. 7 times 7 is 49. Is 7 plus 7 14? Okay, so this factors to be x plus 7 and x plus 7. And then 30 minus 49, what is that, you guys? Negative 19. Well, we can see already what number one of our numbers is going to be, right? It's going to be negative 19. Okay, so what is the short way of writing x plus 7 times x plus 7? X plus 7 squared. Have we accomplished our task of putting this into vertex form? Okay, x plus 7 squared. Okay, so that's vertex form. What's my vertex? Negative 7, negative 19. Remember, you guys, it's the opposite sign of the one that's in parentheses right there, okay? So it's a negative 7. So the correct answer was that first one that Dietrich gave me. You guys are all close. You're getting the right numbers. We just have to get the right sign. Remember, you always take the vertex is, let me show you this right here. Y equals a times x minus h squared plus k. Do you remember the general form of a vertex? Okay, and remember the vertex is h comma k, and you'll notice that that's a minus sign right there, right? Okay, so since that's a minus sign, we have to take, and that's a positive h right there, we have to take the opposite of that sign every time. So going back to this problem right here, see right here it says x plus 7? We got to take the opposite of that, so it's a negative 7. Okay, Stephanie. Do you always take the opposite number right there? Is that what you're saying? Yes. Because this one right here is going to be always plus 49. We have to compensate by minusing 49. Yep, always. Because this one's always going to be positive. Okay? Now, I'm going to answer 3 questions from your assignment yesterday, and then I'm going to give you one more day to work on it. So in case you weren't getting it, we can get it. Okay, hold on. First of all, Sarah, and then Lexi. Can you get a new paper? Yeah, they're right over there. Mr. Rich is sitting somewhere. If you want to get one. Is that what you need? Okay, Max. Okay, number 6. What does it say, Max? Okay, and remember, I told you that we got to rewrite this as y equals. We've got to rewrite it as y equals. How many of you guys got number 6 already? Can you guys find it there? Here's some right here. Right here, you guys. Okay, now, right here, x squared plus 11x minus 12. This one's a little bit different. What makes this one different? Yeah, it's an odd number in the middle, isn't it? Okay, so right here, if I have an odd number in the middle, okay, 11 right here. How do you take half of 11? Okay, what do you get? 5.5. Let's take a poll in here. How many of you guys would like to use decimals? How many would like to use fractions? Decimals. How many fractions? Oh, that's about split. Okay, I'm going to do both of them then. Okay, Morningstar, what are you looking for? This assignment? I think that's the third one I've given you. Okay. All right, so 11 divided by 2, we can leave it as 11 halves. Or what else can we write it as, you guys? 5.5. Why do I have to write the 11 halves? Because it's half of 11. Remember, we take half of the number by the x, and then we square it, okay? So we take half of 11. We can write it as 11 halves, since this is an odd number. Or we can write it as a decimal, 5.5. Okay, so we have 11x right here. Remember, this number doesn't change. It's still 11x. When we took half of 11, we were looking for the number. We were looking for the number that we could get and square it to put right here. That's going to be completing the square. So what number are we going to, what is our number going to be? Okay, so did you square 5.5 then, Max? Okay, what's 5.5 squared? Say that again? 30.25. So those of you who are doing decimals, you're going to write 30.25 here. Since I haven't done one with doing decimals yet, we'll do one with doing decimals. How about you, those of you who are using 11 squared? What is that one? 11 squared. What's 11 squared? 11 squared. 121. What's 2 squared? 4. Remember, because when you square a fraction, all you have to do is square the numerator, then square the denominator, and there's your square. Okay? So those of you who are using 121/4, I will write that one down here. Y equals x squared plus 11x plus 121/4. Okay. And at the end of both of these, what do I have? Outside the parentheses. Okay? Minus 12, minus 12. And then what do I have to do to compensate right here? Minus 30.25. I'm having a minus 30.25 on this one too. Some of you guys are saying that's a lot of math, but I'm doing it both with fractions and with decimals. Thanks, Jody. Okay. All right, so now we have this function right here. I've got to factor it. What does it factor to be? X squared plus 11x plus 30.25. Huh? X plus 5.5, okay? X plus 5.5. Now, Stephanie, tell these guys how you got 5.5 so fast. Squared, right? Because we already knew that 5.5 squared was 30.25, so we knew the number was 5.5, didn't we? Okay? So, and then someone tell me what negative 12 minus 30.25 is. Negative 42.25. Okay, if I was to do the same one on this one down here, you guys, it would be y equals x plus 11 halves squared minus 42.25. I'm going to move this recording device up to here right now. Minus 42.25. Got it? Okay, we're almost done. How do I know it's recording? Because I can see that thing going right there. As long as I have this thing on and that over there. So, anyway. Well, you'll be able to see the screen and hear my voice. Yeah. Maybe I'll show you guys a video. Yeah, you probably won't be able to hear exactly what you're saying, but you'll hear in the background. I'll show you guys a video afterwards, just for a small moment. You guys don't want to watch me twice in one day. All right. Okay, hold on, you guys. Let's finish this one really quickly. I'm planning on showing you that today. Hold on. Okay. All right. Right here, we have x squared plus 11x plus 121 fourths, and x plus 11 halves squared minus 42.25. Okay, now, you got to move this again. Okay, now, we have them both in vertex form already. What's our vertex, you guys, right here? Negative 5.5, comma, negative 42.5. There it is. Or if you use this one, it's negative 11 halves, comma, negative 42.25. Nope, you don't have to change the sign on the second number, just the first one. The one inside the parentheses, you guys. I keep saying that. You guys got to get this down. Okay. How many of you think you got this down now? I just did two different ones of it. It's not really that hard. What? Okay. 11. How did I do the last one? Okay, Trissa gets picked the last one. Keep in mind, you guys, I'm just going to do 3 problems, and then I'm going to let you guys take it home and finish it, and we'll be due next time. I'm just trying to give you guys a little bit more time to understand this, okay? Okay, Chase, tell me number 11. What is it? Okay, you guys, I'm going to do this one without asking you questions, so I'm going to go through it kind of fast so you can see that it's not as bad. I'm going to use fractions to do this one, okay? I'm going to do fractions on this one, and then the last one I'm going to do a decimals, okay? The last one, Trissa's got one more, and I'm going to do decimals. So this one right here is going to be in fractions. Okay, I'm going to do it kind of fast so you can see it doesn't take as long as some of you guys think it is, okay? This is what you do. You group the first 2 terms, first of all. So, and I'm going to show you right here, x squared minus 7x. I'm going to leave a space, and I'm going to put the minus 30. Okay? Since this is an odd number by x, 7 is an odd number, it's going to be a decimal, right? I'm going to take half of 7, and it doesn't really matter the sign because you're going to square it and get a positive number anyway. So 7 divided by 2 is my fraction. And then I'm going to square that number, which is going to be 49/4. So I'm going to add 49/4 inside the parentheses, and that completes my perfect square trinomial. And then I'm going to subtract 49/4. And I'm going to subtract 49/4 on the outside to compensate for what I did on the inside. Okay? Now, the nice thing about this factors to be two factors that are the same. I'm looking for the two numbers I can times together and get 49/4 and add together and get 7. Well, I know already it's this number 7/2. It's the one that you squared. So I'm going to put x, and then since this was a minus, it's going to be minus 7/2. Since there was an x squared minus 7x, it's going to be a negative, a minus. And then all I have to do is add negative 30 and negative 49/4. And let me tell you guys, on this one right here, I need a common denominator. And the common denominator is 4. The common denominator is 4. And I know that I just took this 1 that was underneath 30 and made it a 4. So I've got to times the top by 4 as well. 4 times 30 is 120. Okay? So now I have y equals, okay, I had to get common denominators. The common denominator out of 1 and 4 is 4. So I replaced 1 with 4, and basically I times 1 by 4, so I have to times the numerator by 4 as well. 4 times 30 is 120. Okay, now I have x minus 7/2 squared, and then I have negative 120 over 4 minus 49/4. Well, what's negative 120 minus 49, you guys? It is negative 169/4. And now I have my vertex. My vertex is the 7/2. It's not negative because I take the opposite sign. It's positive. And negative 169/4. Now, if you want to change that to a decimal, you can. But our vertex, that is our vertex. Okay? I know these kind take a little bit more work when that number in the middle is odd, because you have these fractions or decimals. Those of you guys who have trouble with the fractions, use your calculator and do decimals. Got it? Okay, here we go. One more question. Which number? Number 10. Okay, are you guys still writing this down? Okay, I am going to pause this. Okay, Trista, tell me what number 10 says. Okay, I'm going to put the y equals on the front instead of the equals 0 on the back. Okay, here's another one with an odd number in the middle, right? So, once again, I'll do this one as a decimal. X squared minus 15x, I leave a space, plus the 36. I've got to figure out what goes in that space. That's called completing the square. I'm going to make a perfect square trinomial. What's half of 15, you guys, as a decimal? 7.5. Squared. Get out your calculator. 7.5 squared. What is that? 56.25. So we're going to get 56.25 minus 56.25, because remember, we have to compensate by minusing it. Okay, then I'm going to have y equals, and I'm going to factor this into two factors that are the same, because this is a perfect square. And what's my numbers? Y minus what? How do I know it's y minus? Or x minus, not y minus. X minus, how do I know it's x minus? X times x is x squared, right? That's a minus sign. And then what's the square root of 56.25? Well, we already know. We have it right here. It's the number we took and got half. 7.5, right? 36 minus 56.25 is what, you guys? Negative 20.25, is that correct? Yeah, I do it in my head. No, I'm not a genius, but I've been doing this for a long time. It's called experience. Okay. I am a pro. A pro is someone who gets paid to do this. And I'm getting paid. So I'm a pro. All right. So we have the vertex. It's going to be all over the internet now. Someone's just going to edit out and it's going to say, it's going to show Mr. Coon saying, I'm a pro. All right. All right. What's the vertex, you guys? Okay, 7.5, negative 20.25. Any questions on that? Who thinks they know the 4 different ways to represent a function? What are the different ways to represent? Let's name one way you can represent a function. We've been talking about them all year long. What? Graph. There's one right there. Okay. A graph is one. A graph, a linear is a type. That's a type of function. An equation. Thank you, Max. So graph and equation, what? Okay, an XY chart. We call that a table. Wow, you guys are good. I actually didn't think you were going to get some of these. The last one's the hardest one. You guys, okay, we can graph something. You know, that means let's say it was x squared. There's that. Equation, which we call function notation sometimes too. We could represent it like that as an equation. We could write it as a table of values, an XY table. If we put 0, we would get 0 for y. If we put in 1, we get 1. If we put in 2, we'd get 4. If we put in 3, we would get 9. Okay? That's a table. What's the last way we can represent a function? It has to do with expressing it out of your mouth. Verbally. Yeah. Yeah, story problem, or words. Words. That's verbal. We should say verbal. Okay? Those are the 4 ways. Now, I wrote this nifty little slide. Actually, I stole it from someone else. 4 ways to represent a function. I want you to write this down. 4 ways to represent a function. Wait, what was the other way? I'm going to show you right here. It's on here. Verbally, that's the very first one. Description in words. You can describe these verbally. Okay? Verbally. You can describe it in words. Okay, so for example, you could state it as a story problem, like saying, you know, how could you write an equation given that business, you want to know how much a business makes, or how much it's going to cost you to rent a car, and if you have to pay $10 or $20 up front plus 50 cents a mile. Okay, that would be an example of a verbal. Or you can just flat out describe it in words, what you want. Okay? Not in a story problem form. The other way is numerically. That's when we write a table of values, which I just showed you. I hope you guys are writing this down. Okay, so you can use your notes to study from later. Numerically. These are, I'm just re-giving them to you right here, written as how this slide is. Okay? That would be the table of values, the XY table. Okay? The 4th way is visually, as a graph. And the last way is algebraically or explicit function. Visually, I mean, I put it in a different order than we just said. The reason, the other slide, you guys were telling me, and so I put them in there the order you gave them to me. Okay, but this is the order we write them in. Okay, this would be writing it as an equation. This last one right here. Let me see if I can get a color that. This would be an equation. Okay, you guys are going to be watching this at home. And all of a sudden you'll see this word start appearing across there, and you'll think that's so cool, about one time. Yeah, about one time. Then after that it's going to be boring. About what? About being what? Pro. Okay. I'm getting old. I'm getting deaf. All right. Okay. I want to see if you guys can do this. See if you can use your calculator to represent a function in 3 different ways. Okay? 3 different ways. What? Okay, I'm going to pull up my calculator right here, and we are going to do this. Someone give me an algebraic equation. Give everybody, the class, we're going to do this one together. Stephanie. That one won't show up on there. Do the 16, make it a negative number, small negative number. Okay, there you go. Okay, everybody. Did you guys all hear what she said? So she said, I said, give us one algebraically, and she made one up. She said y equals x squared. So go to your calculator, put in x squared. Then you said plus 6x, right? Plus 4x, sorry. Plus 4x minus 6. This one will show up on here, okay? Now, everybody, so we have the same window. I want you guys to hit zoom. Oh, wait. Zoom, and then 6 is standard. Okay. How many ways have we represented this function so far? 2 ways. Okay, so everybody write this down, first of all. Okay, one way, number 1, we represented it as y equals x squared plus 4x minus 6. The second way we represented it was with the graph right here, right? What was the graph? Well, it looks like this. We're going to kind of just do a rough drawing of it right here. There's the graph. That's the second way representation of it. And what's a third way I can use my calculator to represent this graph, you guys? Okay, second and the table button. Everybody, do this first. We got to set up our table. So everybody hit second and window button. Hit second and window button, or you can just sit there and stare into space, like some of you guys are doing. Okay, Cody. Okay, Cody, get out your calculator. Type this in there. Okay. All right. So table start is 0, and table we're going to start at 1. That means, you guys, we are going to start at x equals 0. That's what the table start is. And we're going to start going up in 1s. So it's going to start at 0, and it's going to go up 1, 2, 3, 4. Now everybody hit second and graph, because you know, notice above it says table. There's a table, an xy table. When x is 0, y is negative 6. When x is 1, y is negative 1. When x is 2, y is 6, and so forth. So let's write that on here. Notice right above the graph button, what does it say? Table. So you have to hit the second button and the graph button to get to table. So we have 0, comma negative 6, 1, comma negative 1, 2. These are all points of this graph, of the equation and the graph. 3, comma 15, and we're going to have to minimize this. 3 comma 15, 4 comma 26. No, because guess what? How far does this go, you guys? I can even go in the negative direction. I can go -1, -2, -3, right? -4, -5, -6. I can go in both directions as far as I want to go. How far can I go? I can go on for infinity because the domain of these is all real numbers. Say that again, Chase. Yeah, it will keep going forever. You can see the values of y given x. Okay, pretty cool, huh? So you guys know how to use your calculator to represent a function in 3 ways. Will the calculator represent this function in the 4th way? Why not? Because the calculator doesn't do the verbal description, does it? Could we write a verbal description of this? No, I mean, could we write it on here? We'll do number 4. Number 4. Could we write a verbal description of this function? We could. It would be kind of difficult. We could. What are some things we could describe about this function? Could we name its vertex? We could name its vertex. Okay. We could name whether it goes up or opens up or down. We could say that the a value was 1. Okay. We could state the x-intercepts and the y-intercepts. So we could do all that to state it verbally, but it probably isn't worth it on this problem. Okay. There's some problems where it's more important to name it verbally. Okay. All right. Okay. You guys, next slide right here. I want you to look at this. Which function has a greater average rate of change over the interval 5, 10? So notice, which way did we represent this function right here? As an equation. And which way did we represent this one? As a table. Now, do you think they're the same functions? How could we check to see if they're the same functions? What do you mean through the numbers? So in other words, make an XY table? Okay. Put 0 in there. What do you get? 4. But over here, when x was 0, y was 300. So are these the same? No. Okay. Put 5 in here. What's 5 squared? Plus 4 is 29. Put 10 in here. Okay. All we're doing is we're just putting numbers in for x. We put them in for x right here. Like we took 0, put it in. What's 0 squared? Plus 4 is 4. Does that make sense? I just chose 5. The reason I chose 5 is because these numbers over here, they gave us x numbers and y numbers. This is a different function, just represented as a table, than this one right here, okay? So I'm choosing the same way. Notice the question asks on the interval 5 to 10. Chase, you were asking this. The interval 5 to 10. And so that's why I put 5 and 10 in there, is because this one already has 5 and 10. This one's 5 and 10. I can check the average rate of change if I find 5 and 10. If I put 10 in there and go 10 squared plus 4, what am I going to get? Chase? If I put 10 in right there and went squared plus 4, what am I going to get? 104, right? Okay. You guys remember how to check average rate of change? How do you get to the table? Go like this. See the table? It says above graph. You hit second and table. Okay. Hold on. I'm almost done. Okay. Okay. Look, you guys. We're going to find the average rate of change. You guys remember? How many of you remember average rate of change? We talked about it 2 weeks ago. Okay. Average rate of change is to find the slope. Remember, average rate of change is slope. I'm going to find the slope on the interval 5 to 10. Well, 5 to 10 is these numbers right here, right? And 5 to 10 on this one is these numbers right here. So all I'm going to do is find the slope. Well, remember the slope formula? y2 minus y1 over x2 minus x1. That's the slope formula. Chase, you remember that formula? Huh? Okay, now watch. I'm going to go y2 minus y1 on this one. Well, I'm going to use this point as y2, y1. What's 104 minus 29? So 104 minus 29 over 10 minus 5. And that's going to give me, what's 104 minus 29? 75. What's 10 minus 5? And what's 70? Yep, this is slope. 75 divided by 5 is 15. Okay, let's check this one down here. We're going to need calculators for this one. y2 minus y1. So 1,010 minus 777.5 over 10 minus 5, which is, someone get out your calculator. What is it? 2, what? I need one person talking because you're all saying 232.5. Does everybody agree? Over 5. What's 232.5 divided by 5? 46.5. Now, you guys, the question again. Which function has a greater average rate of change over the interval 5 to 10? This one has a slope of 15, or the one at the table that has a slope of 46.5. Which one? Yeah, the table does. Okay? Has a greater slope. The table has a greater slope. Yes, it is.